Welcome to the explainer. So, if you've been working with standard single variables up to this point, you know they're great for simple tasks. But real-world data, wow, it's a whole different beast. It's massive, it's complex, and it almost always comes in collections. Today, we're totally upgrading your toolkit. We're making that exciting transition from handling isolated, single values to managing actual real-world data collections using Python lists. So let's dive right in, shall we? Think about a single variable, like a mark of 85. That's completely fine if you've only got one data point. But honestly, that highlights the core problem data analysts face every single day. You aren't just looking at one value, right? You're handling hundreds, thousands, or literally millions of data points. You simply can't create a separate variable for every single value. That would be a nightmare. But there's a brilliantly simple solution for scale, the Python list. We just group all those numbers together inside square brackets. Boom. One variable, entire dataset. It's a total game changer. Here's our quick roadmap for today's journey. 1. The data analytics foundation. 2. Navigating your dataset. 3. Shaping and cleaning data. 4. Automating with loops. 5. Real-world sales analytics. And finally, 6. Avoiding common coding mistakes. Let's get to it.
Starting off with Section 1, the Data Analytics Foundation, Building the Pipeline.
Python lists really are the ultimate foundational solution for organizing raw data. By definition, a list is simply a tool used to store multiple values in a single variable. But let's make that concrete. Think about it. In real life, a Python list is incredibly similar to a single Excel column. If you picture a spreadsheet column totally filled with sales figures, or maybe temperatures or survey results, you instantly understand what a list actually represents in a professional analytics setting. It just completely demystifies the code. And when we ask Python to print that list, it's beautiful, just a clean, incredibly efficient grouping of our dataset. It takes all those separate, messy numbers and neatly packages them into one manageable object ready for analysis. Moving on to Section 2, Navigating your dataset, Locating specific data. Okay, so now that we have our dataset neatly packaged, an analyst actually needs to know how to extract the exact pieces of data they need. Take a look at these index values. Notice anything a little unusual? Yeah. Python starts counting at 0. So the absolute crucial point here is that the very first item in any Python list is always at index 0. 85 is at index 0, 90 is at index 1, and so on, down the line. It takes a second to get used to, I know, but it is the absolute law of the land in Python analytics. So let's say we write our list name, marks, followed directly by square brackets and the number 1. The output? 90. Boom. We just successfully extracted the second value from our dataset. Mastering this zero-based extraction is, well, it's absolutely crucial because accurately pulling specific data points is the bread and butter of literally any analysis you'll do. Next up is Section 3, Shaping and Cleaning Data, Filtering and Modifying. Here's a hard truth. Real-world data is almost never clean. It's messy, it's chaotic. So these next functions are your primary toolkit for whipping that data into shape. First up is slicing. Let's say you don't want just one value, you want a whole chunk of values. By using a colon inside the brackets, like marks bracket 0:2, we're telling Python to grab a slice. The output is 85 and 90. Slicing lets you grab specific chunks of data effortlessly, effectively filtering out all the surrounding noise. Now, you might be wondering, why does this matter so much? Well, explicitly speaking, slicing is exactly how an analyst zeroes in on a specific time frame or a target metric. Imagine you have a massive list of 365 daily sales totals. Slicing is exactly how you'd instantly isolate just the first 30 days to look at a monthly trend. It's super powerful. But what happens when the data inevitably changes? This builds beautifully into modifying your lists. Let's look at step 1. We use marks.append95 to automatically drop a brand new value right at the end of our dataset. And in step 2, if we spot a bad data point, maybe a sensor glitch or a typo from data entry, we use marks.remove78 to just pull it right out. This completely simulates a live, real-world data cleaning scenario. All right, Section 4, Automating with loops, Scaling your analysis. Up to now, we've only been looking at tiny little lists. But if you're dealing with massive volumes of data, doing things manually one by one simply is not an option. We need scale. Enter the for loop. For mark in marks, print mark. This simple, elegant piece of code automatically iterates through every single item in the entire list, step by step.
If that list has 4 items, it runs 4 times. If it has 4 million items, it runs 4 million times, without you having to lift another finger.
In fact, the source material directly emphasizes that loops are, quote, very important for data analytics. They are absolutely foundational. If you want to automate your analytics tasks, like, say, applying a specific tax rate to thousands of prices all at once, loops are exactly how you unlock that power.
Let's bring it all together in Section 5, Real-World Sales Analytics, Seeing It in Action.
Okay, let's take everything we've just learned and apply it to an actual practical data set to see just how powerful this really is. Here is our raw data visualized: a sales list with 1,000, 2,000, 1,500, and 3,000. Seeing it visually like this brilliantly bridges the gap between raw Python code and actual visual business analytics. You can immediately see the fluctuations in the sales pipeline across these 4 periods, right? Now imagine the boss walks in and wants to know the total revenue. Instead of manually adding these up on a calculator, we use built-in functions. Total equals sum sales. You just wrap the list name right inside that sum function. Then we print that total. It is an incredibly simple yet devastatingly powerful piece of syntax used to calculate the sum of an entire dataset in literally a fraction of a second. And the output, 7,500. Take a second to really appreciate that. That is that deeply satisfying aha moment of completed real-world analysis. You took raw, separated numbers, grouped them into a list, processed them, and outputted a clean, actionable business metric. That's data analytics in a nutshell. Moving to our final section, Section 6, Avoiding Common Coding Mistakes, Troubleshooting like a Pro. Now, of course, it isn't always perfectly smooth sailing. Let's be real. Every single data analyst on the planet makes errors along the way. It's how you fix them that matters. Looking at these 2 approaches, one shows values separated by commas but no brackets. That is definitely the wrong way. Python will absolutely not treat that as a list in the way you want. On the other hand, we have the crucial square brackets. Forgetting those brackets is basically a rite of passage for coders, but it breaks your data formatting immediately. So always remember your brackets. And then there is the dreaded index error. Imagine you have a list of exactly 4 items, and you write marks bracket 10. You are effectively asking Python to look in the 11th filing cabinet when you only bought 4. Python panics, throws an error, and completely crashes your program. So always make sure the index you're looking for actually exists within the physical bounds of your list. All right, let's lock this knowledge in. Here's an immediate, actionable practice task for you. Try this out. Create a list of numbers, 10, 20, 30, 40. Then, try printing out index 2. Remember your zero-based counting. Finally, append the value 50 to the absolute end of your dataset. Doing this hands-on practice will completely cement this brand new analytics toolkit in your mind. Lists are an absolutely incredible foundation, but honestly, they're just the beginning of how we structure complex data. What happens when you need to pair a specific customer's name directly to their individual sales total? That leads us to our next big question. Are you ready to take your data analytics to the next level with Python dictionaries? Think about how insanely powerful that could be. We'll explore exactly how to do that next time. Until then, keep practicing and keep exploring your data.